The Arduino Educator Kits is designed with a clear purpose to offer the best learning experience for beginners entering the world of Arduino, coding, and electronics. It's not just about teaching how things work, it's about enabling users to validate their experiments, code, and data buses, which is crucial for those passionate about enhancing their technical skills. The kit includes an Arduino board, Educator Logic Analyzer, breadboard, I2C to LED module, LCD display module, test hooks, test wires, sound sensor, USB transfer module, and a practical guidebook. The guidebook features 8 hands-on experiments in a fun comic-style format, complete with real setup diagrams, real-world applications, and experiment files showing how to verify results using the logic analyzer. You don't need any advanced electronics knowledge, just follow the step-by-step chapters, and you'll easily learn while enjoying the process. What are the main functions of the Arduino Uno? We upload the written code to the Arduino Uno to operate its various functions, such as GPIO, I2C, and UART. In order to implement applications like LEDs, LCDs, sensors, and motors. First, we need to set up the Arduino Uno in advance and download and install the ZP Logic Analyzer software. This ensures compatibility between the device and the software, allowing for smooth data capture and analysis. Next, we will guide you through these steps to make sure everything is ready for signal analysis. 1. Downloading Arduino software. Navigate to the official Arduino website. Click on the software page. Select the Windows version for download. Web browser starts downloading the Arduino software. Download completes. 2. Downloading from Zero Plus website. Visit the official Zero Plus website. Go to the download page. Select the relevant product. Choose software search. Click Web to start the download in the browser. Click on the description. Copy the Arduino sketches URL. Open a new web browser tab. Paste the URL. Press Enter to start downloading. Download completes. 3. Installing Educator software. Install the Educator software. Run setup.exe. Select Accept. Enter a username. Installation in progress. Installation complete. ZP Studio is now in the Windows Start menu. We have prepared 2 case study demonstration videos using the Educator software and Arduino kits. These videos showcase practical applications. One focuses on controlling an LED via I2C, while the other walks through the setup of a UART signal board simulation. Setting up Arduino IDE. Open arduinoide.exe. Set up the connection to the Arduino Uno. Configure the COM port connection. Configure board settings. Select Arduino AVR boards. Choose Arduino Uno. Configure the port settings. Select the corresponding Arduino Uno COM port. Use the Open feature. Open previously downloaded Arduino sketches. Open the I2C Control ED code. The board and COM port settings are retained from previous configurations, so no need to reconfigure. Show the example code. Includes definitions for GPIO and I2C. Execute the upload function, compile then upload. Arduino IDE restarts the Arduino Uno after uploading. Next, we will demonstrate how to use the Educator Logic Analyzer for signal analysis. Logic Analyzer setup using ZP Studio. Open the ZP Studio software. Enter the main screen to set up the Logic Analyzer. Open sampling settings. Set the sample rate to 1 MHz. Set memory to 2K. Set trigger level to 5. Set trigger position to 10%. Press OK. Configure the trigger condition on A0 as a falling edge. Configure the trigger condition on A1 as high. Start the capture. Next, to analyze I2C, we will configure the I2C properties to analyze its packets and waveforms. Press the button on Arduino Uno pin 9. Use the Display All feature. Select the waveform area with the mouse and zoom in. Click on the I2C decoder. Check channel settings. A0 for SDA, A1 for SCL. Check data settings. Press OK. Change numeric base to hexadecimal. Observe the address and data to see the I2C command controlling the LED, causing it to emit a green light. The next experiment will use the ZP simulated signal board and the educator analyzer to analyze UART signals. This will demonstrate how to capture and interpret UART data transmission, aiding in more precise signal analysis. Open the educator software. The software name is ZP Studio. Enter the main screen of the software to configure the logic analyzer. Open the sampling settings. Set the sample rate to 1 MHz. Set the memory to 32K. Set the trigger level to 3.3 voltage. Set the trigger position to 10%. Press OK. Set A0 as the trigger condition for falling edge. Start capture. Use the display all feature. Click on UART decoder. Check the channel settings. Check the baud rate settings. Use automatic baud rate detection. Press OK. Use the mouse to zoom in and clearly see the packets. Change the numeric base to hexadecimal. In addition to using a signal simulation board, we can also write a code using Arduino Uno and use the educator logic analyzer to analyze UART waveforms and decode them. Please refer to the following practical example. Open Arduino IDE. Use the open function. We have written the program for the UART transmitter function. Set the board to connect to Arduino Uno. Set the port to connect to the COM port. Display the written code. The program also has I2C functionality. Execute upload. Upload complete. Arduino Uno pin 1 will regularly output UART signals. Open educator software. The software name is ZP Studio. Enter the software main interface and set up the logic analyzer. Open sampling settings. Set the sample rate to 1 MHz. Set memory to 32K. Set the trigger level to 3.3 voltage. Set the trigger position to 10%. Press OK. Set A0 trigger condition to falling edge. Start capture. Use the display all feature. Select the area with waveforms with the mouse and zoom in. Click on UART decoder. Check the channel settings. Verify baud rate settings and use auto detect for baud rate. Press OK. Change numeric base to ASCII code. Observe the packet content. Open the packet list. Packets are arranged one by one. Enter decoder settings. Open packet interval setting to combine packets from the same segment into one row.